The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI Web Sessions are recorded at ACI Conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI Conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
Our next speaker is Mr. Mike Cook. He's the quality control manager from Granite Rock Company, and he will present us the use of SCC in seismic joint retrofit. Welcome, Mike.
Thank you. So last Memorial Day and Labor Day, we had opportunities to work with California Department of Transportation and AMAC Consulting Group to basically do a couple SCC joints. Basically, there was 17/16 steel plate overlaying an SCC joint. Holes were placed approximately six feet apart in the joint. The side forms on the placement were not very strong, so the contractor had some concern about blowout, so he didn't really want to put a lot of pressure to it. And as we've heard previously, a lot of people like to put a lot of velocity to it to stay out of segregation and that sort of thing. But since there's been so much talk about a lot of sort of the detail that's in SCC in the previous presentations, I'm going to modify this slightly and really talk about this from the standpoint of communication. You know, when you think about concrete, there's a technique called anticipatory failure determination. Anybody familiar with it? Where you essentially take a project, a concrete wall, and if I asked you how many ways you could possibly make that fail, how many ways do you think you could come up with to make that wall not meet the specifications? Well, the answer, you know, having been in quality control long enough, anybody that's been in concrete long enough, is there are millions of ways to make it go wrong, right? Well, if you think about SCC, you can just up that ante to 1 million plus maybe another couple 100,000, right? Because it just has more sensitivity in general. And this is kind of a story of, quote, sensitivity, planning, and communication, and all the places where it can go wrong. So let's move on here. And so here's the general, you know, what we learned and what you already know. It's the need for very specific detail up front about what you want to do and what needs to be done. Clearly, not everybody has the same materials, so you know, when a specifier goes into an environment, a generalized specification is just that. It may not be adequate, right, for the specific application. And there needs to be flexibility, and there really needs to be close partnering and communication in the developmental process. As I already said, there's really more complexity with SCC. There's no doubt, and believe me, we learned a lot. So here's a picture of the joint prior to the plates being placed on the top here. The mix design specification was fairly generic at Caltrans. Follows ASTM to some point. I mean, big test. I mean, it was pretty straightforward with respect to, you know, it required a minimum of 21-inch flow, but it was subject to what the contractor actually wanted. The contractor in this particular situation did not have a lot of experience with SCC, so they relied on us. And well, we started with the 23 to 24. The reason is we were trying to avoid segregation in it. So going to a higher, more flowable material obviously would create an issue if we weren't careful. So we tried to start with a lower number. We started our process of development essentially a year in advance of the first placement. California had a requirement for a minimum of 25% supplementary cementitious substitution in all of its mixes. We received the specification from our sales staff. Lesson 1 with communication: when you get something from the sales staff, make sure it's complete. They failed to inform us that there was also a requirement for 2,000 psi in 24 hours so that they could reopen the bridge to 61,000 vehicles per day of traffic. Nobody told us that at the lab. So we basically designed our mix and actually went out to the first mock-up trial that, thank goodness, was part of the process. We were really trying to simulate what the pour would be like in advance. And we got out there and did it, and then the engineer says, oh, by the way, this will make 2,000 psi in 24 hours. And we said, well, I don't think it will. It made about 700 psi, I think. And it was really about a 7,000 psi mix. So anyway, so we kind of had to go back to the drawing board. The good news is that we're 6 months from when the job was to begin. So we went through a series of processes to start to develop a mix. Now, in terms of the total yardage for this job, I think each joint was only 25 or 30 yards. Of course, the liability in it, in not being able to open a bridge on time, was really, really significant. So in retrospect, the degree of attention given by our sales staff to the liability of this wasn't all that huge. In addition, they didn't want to spend a whole bunch of money, so they didn't want to necessarily dose with accelerator, put a dosing trailer together and all that sort of thing. They'd really rather prefer that we do the whole thing at the plant. So we needed to have a high flow mix that would accelerate quickly to gain the strength required to open the bridge. So the challenge was to figure out how to get that done. And as some others have talked about here, well, now, every SCC mix is unique. In this case, a secondary requirement of us was to basically use only our aggregates, right? Our company's aggregates, right? Management doesn't like you using other folks' aggregates in any sort of blend, if you can help it. So we have a gabbro diorite similar to a granite. This was the half-inch material. It has a specific gravity about 2.8. The sand actually, and the rocks has a nice shape. It's fairly cubical. It's pretty good that way. The sand, on the other hand, for a standard 6-sack, it's about requires about 35 gallons per yard to get you a 4-inch slump. So it's fairly water intensive. It doesn't really want to flow. Once you get it in place, though, it's a really nice actor. To help us a little bit, this is a little fine river very rounded sand, specific gravity about 2.61. We were able to add about 20% of it to our mix to kind of improve the flow characteristics of the mix and reduce the water requirement. So we started with these, put a mix together to try to assure that we got the strength. So Caltrans limit on cement or cementitious material in mix is 800 pounds. So we used all we could, and this was simply about getting the strength. Fairly low water cement ratio, and a whole bunch of admixtures. So it probably took us a little bit longer than we expected to really get the mix dialed in, but this is probably why. There were 3 guys talking and 1 guy working. And that happens sometimes. I'm just kidding, of course. But anyway, we really worked at it, and like some of the gentlemen said before, it isn't so much about what comes out of the truck initially, it's what's going to come out at the very end of the process. And so we sat on site with the truck, and we tried to simulate the entire length of the job before we took mix out of the truck. And it was only when we had the slump flow that we wanted and the segregation and the temperatures that we wanted, that we thought we were close to being ready to go. I'm not quite sure what happened to that slide, but what this slide, anybody have an idea what happened to that slide?
Can you please talk to the recording?
Oh, sure. Sorry. Well, anyway, underneath the slide was the actual mock-up. It was a really nice 8 by. Pardon me? Yeah, it was about an 8 by 8 form. I think about a foot deep with a polycarboxylate top over it. The actual placement was an inverted safety cone, right, with about a 2.5-inch hole, and then we were just gravity feeding it and having it flow across the entire form, fill it, and then once it was filled, to check segregation, 100 pounds of aggregate was taken off either corner, and the allowable segregation at that point was 15% difference in total weight. Well, the first time through with this very low velocity, we were at 18%. And meantime, I was continually encouraging the contractor to let us use a pump to give us just a little bit of velocity, and we could probably make it. So finally, they agreed to do that, and we thought we were pretty much set and ready to go. I mean, we had essentially a mix that didn't segregate. We had sort of a temperature regime that we thought would work. We trialed the truck with the amount of material in it that we intended to have in the trucks going over. Just tried to simulate as best we could. So here you see the actual plates being placed with the holes in them, ready to go and all that sort of thing. And we thought we're ready to go. So then we did our first placement, and because it was on the Memorial Day weekend, there were really a few things that came up that we hadn't really thought through, frankly. And the first is we're in the Bay Area of California, which is relatively damp most of the time. We don't get a lot of dried out aggregates or that sort of thing. Temperatures generally in the 60s to 70s, not real warm. Well, since this was such a small pour, it turned out that the material that was in the bunkers was not fresh. It had dried out. The temperature was elevated by about 10 degrees. So when the first load came out, the slump flow was there at the start. By the time it got to the job, we'd lost a few inches. We didn't test at the site as was so wisely recommended here. And the next thing you know, we've got a slump flow of probably 19 or 20. It jammed up. It jammed up the flow. And so the next thing that's happening is the contractor's blowing additional holes in the iron to basically get the material in place. He's getting out his vibrators and vibrating away. And anyway, it was very interesting, to say the least. But there were a few other things that came up as well. When we showed up to actually do the placement, the salesman informed us that the contractor decided that he didn't want to go with. We were asking for 4 yards per truck based on what we thought the timing would be and that sort of thing. But the contractor wanted to do 6 yards, and so at the last minute, the salesman said okay. And so not only did we have this flow issue to start with, now we had a time length issue as well on the trucks being on the job, of course, which was exacerbating the issue. The last component that wasn't anticipated was that there was a certain amount of steel in the form that was originally supposed to come out of the form. It was a residual steel from the tearing out and preparation and tie-in that they decided to keep in the slot, so that when we did the mock-up, it really didn't replicate exactly the amount of steel in the mix at all. So it was like a perfect storm. our lack of foresight about aggregate moisture and temperature, a little change in the quantity and the time the material was actually going to be available in fluid in the truck, and then lastly, a little bit more steel in the form. Thank God we made it, right? Because the nightmare is, right, every news agency in the Bay Area was there. I mean, I think that there were more news people there than there were workers on the job. And the whole thing is about this bridge being closed over the Memorial Day weekend, and it's supposed to be open at a certain time, and fortunately we made it. So that was joint number one. Now we had joint number two to do in September. And this is actually a picture from the Memorial Day learning experience. But nonetheless, the second the second pour went very, very smoothly. We did a few things. We actually increased the slump flow. That was critical. We had additional on-site management to assure that if anything did occur, we had the ability to basically increase the flow by adding additional admix. We had much better communication with the contractor to assure that there weren't any changes in form. They put 2 pumps on the job because they wanted to make sure that they were working on it as fast as they possibly could. They actually put a few more holes into steel than they had the first time. They didn't need them in the second time. And it all came down to really having very, very good communication between internally with the supplier, between the contractor and the supplier, and also with the specifier and the owner during the project. Ultimately, it worked out very well. Again, the challenge was having to get this thing to get to strength fairly quickly. So we had to accelerate and control it, which we're able to do by using essentially hydration stabilizers and an accelerator that had a slower start, heat up. It gave you an extra 25 minutes or so before it really started to kick off, and then that was quite effective in giving us the time we needed without getting any sort of additional loss in flow or slump. That's it.
Thank you very much. Any questions for Mike?
Any questions?
Yes.
Just out of curiosity, the curing process, because of the short time table you had to pour and then open the bridge, was there
No, there was no special curing. No, the material got really warm quick, so yeah.
But it was all underneath the steel.
Yeah, it was underneath the steel plate.
Yeah, covered. Yeah. Thank you, Mike. Thank you very much.